Hey, Fraser, if you're interested, I have 2 tickets to tonight's throat singing concert.
Don't toy with me, Niles.
What the hell is throat singing?
Oh, Dad, it's an extraordinary technique where a single vocalist can actually produce 2 distinct tones simultaneously, allowing him to harmonize with himself.
Kind of like the Everly Brothers.
So if you're watching this, there's a good chance that you're probably feeling a little bit like Marty Crane here. Don't worry. Today, Sean and I are going to explain a little bit about the history and the mechanics of throat singing.
The throat, or overtone singing technique, has been going on for thousands of years. It is specifically related to some of the nomadic farming and spiritual traditions of its people. Throat singing has its origins in the indigenous Turco-Mongol tribes of the Altai and Sayan Mountains in western Mongolia, northern China, and southern Siberia. These areas are part of the Central Asian region known as Tuva. The technique is used among the nomadic and semi-nomadic people groups of the region. There are different types of throat singing techniques, but the most well-known, and the one from which many others have derived, are from this region. Now, there are a number of different named styles or subtypes within the technique based around the people groups in this region, but the general technique of Tuvan throat singing is referred to as Khume. These different styles are developed specifically in order to mimic different sounds occurring in nature or animal sounds, and as they relate to the religious and spiritual understandings of the people. Many of these singing techniques were actually forbidden during much of the 20th century by the communist regimes in Russia and China because of its association with its ritual cultures. It became revived as a national art form starting in the 1980s, with the downfall of the USSR, and has been experiencing great revival since then. Now that we have a cultural context for this art form, let's dive into what is happening musically. The way that we get this harmony within one singer is by using and manipulating the naturally occurring musical phenomenon known as the harmonic series. Now, what is the harmonic series? The harmonic series is the mathematically perfect series of frequencies that occur when you take integer or whole number multiples of a fundamental or starting tone. Now, the mathematical relationships between the notes of the harmonic series is always the same in their ratio, no matter what note you start with. Let's explain it from the point of view of a resonating string. This is practically shown by taking divisions of this resonating string. Playing the open string gives you your fundamental note, or your starting note. If you place your finger on the exact middle of the string, you get your first partial, which is the first note above the fundamental on the harmonic series. This first partial is 1 octave above the fundamental tone. If you place your finger 1/3 up the string, you get your second partial, which is an octave plus a fifth above the fundamental pitch. If you place it 1/4 up the string, you get your third partial, which is 2 octaves above the fundamental tone. This pattern continues with a decreasing numeric amount between each partial as we move up the series to the higher notes. Now, these harmonic partials are all present within the sound we get when we hear the resonating string sounding, though we may not be able to hear them noticeably. But what these divisions do is help break them down and focus on each partial individually. So essentially, what overtone or throat singing does is access and bring to the foreground an individual harmonic partial while you are still singing the fundamental tone.
What a mind-blowing collision of music and math. Now that we have an understanding of what the harmonic series is, there is just one burning question. How on earth do they do that? Before I get into the phenomenon that is being able to, as Sean said, bring an individual harmonic partial to the foreground with one's voice while also singing the fundamental tone, I think it's important to scale back. Since we're already acquainted with the concept of a vibrating string, let's build our knowledge of the voice upon that. Alright, think of a violin. You've got the body, the neck, the strings, and so on. First, I'd like for you to imagine the sound that would result if someone were to pluck the string. Got it? Cool. Next, let's change the mental image a bit here. What if I were to take away the body of the violin and just pluck at the string? How does that sound? Can you even hear it? Can you identify the pitch? Not really, no. Okay, one more mental image here. Picture your violin back to normal, but then take the body, scrunch it up, and pluck the string. How's that sound? Is it resonant, full, and strong? No. Your voice, much like the violin, is equipped with a power source, like the bow or the person plucking the string, a source of vibration, aka oscillator, which would be like the violin string itself, and a resonator, like the body of the violin. Now, just real quick, don't let my comparison of the vocal folds to the violin string confuse you too much. The vocal cords or folds are not technically actually strings. They're like violin strings because they function as the oscillator. The vocal folds are our source of vibration, and the vocal tract is our resonating space. So here's how this works. The power source is the air we release upon exhalation. When we exhale and go to speak or sing, the vocal folds come together, and as air goes through them, they vibrate. The amount of vibrations per second determines the pitch that's produced. For example, if I wanted to sing an A440, that means that my vocal folds have got to vibrate 440 times per second. As you can see from my little diagram here, the voice is somewhat complicated. If this is a lot to take in, don't worry too much. The main thing you need to understand for our purposes as future overtone singers is this. The vocal folds are the oscillator, the sound source, and thus the source of harmonics. Now, we gotta get into the vocal tract, aka our resonator. Wanna know what's cool? The human voice is the only instrument whose resonator is able to change shape. Remember how bad it sounded mentally when I told you to fold over or scrunch the body of the violin and then pluck the string? Well, fortunately for singers, the vocal tract offers us a lot more flexibility. Let me show you. So, Voice Science Works defines the vocal tract as a container of air that starts from the top of the vocal folds and goes all the way to the edge of the lips. I've sort of given you a close proximity here on my diagram. All along this tract, which is going to be in the blue that I've drawn for you here, are muscles which we can either directly or indirectly manipulate in order to change the shape of the tract, thus determining which traits of the original sound we want to bring out. So to sort of summarize that a bit, the main thing we use to adjust the size and shape of certain areas of the vocal tract are the lips, tongue, pharynx, larynx, jaw, and soft palate. These are all things that affect the size and shape of the vocal tract. This is where we get into overtone singing. Finally, you might be thinking. Alright, we're gonna get down to some very basic vocal acoustics. Don't panic, it's super simple. So, overtones are a natural part of the vocal sound, but in order to achieve overtone singing, we need to divide the tract into two different resonances so we can highlight specific overtones. In this context, I'm using the word resonances to refer to physical areas within the vocal tract where certain frequencies sound stronger. Do you remember that fundamental frequency? Well, that is usually going to be produced in the laryngeal pharyngeal area, aka your throat. And then we need to get our second frequency, which we're going to accomplish by changing the shape of the tongue to change the shape of the vocal tract. And to do that, all we need to do is sing different vowels. It's one thing to hear me talking about all these things like resonances, vowels, tongue position, so on, but I think it's a lot simpler and a lot more fun if we could just try this together. So we're going to start with our fundamental frequency. For example, And then we're going to change the shape of our vocal tract by moving through some vowels while singing that. So what I'm going to do is start with and then the lowest harmonics are emphasized with an oo vowel, oo. And then as you change between different vowels, the higher harmonics are going to be able to be heard. So play with this for a second, moving through the vowels o, a, e. O, a, e. Now we're going to add this sound. So finally, here's a demonstration from the great Anna Maria Hefele. She can really isolate those frequencies.
Komm lieber Mai und mache die Bäume wieder grün und lass mir an dem Bache die kleinen Veilchen blühen. Wie möchte ich doch so gerne ein Veilchen wiedersehen. Ach lieber Mai, wie gerne einmal spazieren gehen.